We are all on time. My name is Karok. I'm the director of the Mays Innovation Research Center here at Texas A&M. We have a great fireside chat today. Before I dive into it, wanted to tell a little bit about what we are and what we do. So I'm an economist. I'm a professor at the Mays Business School at Texas A&M. I founded a research center called the Mays Innovation Research Center to really understand innovation and how it works, and to help spread that knowledge across our campus and beyond, and really to inspire our students to be more innovative in the future. And that's I think the mindset that we approach all of our events, in the sense that we want to encourage young people, the young generation, to think big, take big risks, and shoot for the moon or beyond. And so we do a lot of different activities. We have several conferences that we run every year. We bring speakers to campus, as well as do these online chats. We fund a lot of research across campus. So I hope all of you watching can get engaged with our center in some way. And David, we would love to host you in person in Texas. Hopefully you can take one of your jetpacks and fly here when the time is right.
Or one of the flying motorcycles, Karok. Right. That would be great.
Yeah, exactly right. So, okay, so let me get to it. So what we'll do, just for format, David and I will have a fireside chat, and then anyone else who has questions, just put them in the chat function, and we will read them off at towards the end of the conversation. We'll have open Q&A, and I will, this will be pretty casual, so we'll probably wait till the end. But if the questions pile up early, we'll maybe I'll stop talking earlier. So let me first say I'm delighted to introduce David Mayman, who is the CEO and founder of Jetpack Aviation. So he is a citizen of Australia. He's based in California. He has several pilot's licenses across several countries. He earned his undergraduate degree in business management from the University of Technology in Sydney, which is a place I need to pay a visit to. He had a career in management consulting, in mergers and acquisitions. Very interesting background. He started companies like True Local and Your Local. We'll get into more detail about his past. And then in 2011, he essentially went on to execute what was my childhood dream, which was to, when I grew up watching G.I. Joe, the Great American Hero. I don't know if anyone else in the audience did, but this was sort of Duke, he's wearing a jetpack, and really was, all of my figures all had jetpacks. And for me as a kid, it was always, it was just a dream, and just to see that come to reality is truly amazing. So I'd like to welcome David and first say thank you for taking the time to speak to us.
Absolute pleasure, Karok. Thank you, and thanks for everybody else that's attending. Great to be here.
So David, just to get us started, if you could, one thing we want is our students in the audience to kind of figure out how you got to where you were, and what decisions you made, and how you got to this level of kind of breakthrough innovation. Can you trace back a little bit of your story, your youth, insofar as what do you feel like was elemental in bringing you to the point of creating, personal flight, making that a reality?
Yeah, sure. And let me tell you, I've made a ton of mistakes. So don't do everything that I've done. And one of the things that I've learned is that there is no fixed path to getting to where you want to get to. So I was born and bred in Sydney, Australia. I think I started off really lucky, in as much as my parents didn't try to corral me into any particular career or mindset. They were pretty laissez-faire. They were pretty open. So I grew up as a kid thinking pretty much anything was possible if you gave it a shot. That led to me literally spending a reasonable amount of time in hospital. I can tell you that right now, because my passion was from day one aviation. It seems to run in the family. My uncles fly, my grandparents fly. And so I got the bug pretty early, but I could never afford to do any kind of flight training. I came from pretty humble beginnings. And so I used to do stuff like build my own parachute out of canvas sacks that I would cut up, and tried jumping off sea cliffs in Sydney that might have been 40 or 50 feet tall. Crazy crap like that. I tried building a gyrocopter using a lawnmower engine and old helicopter rotor blades, and probably when I was about 13 or 14. The great thing was the way that I grew up. My folks never said, "Oh, that's crazy. You're batshit mad. Don't go down that track. You're wasting your time." They were very supportive, and not everybody gets that start, and I fully appreciate that. So yeah, did a Bachelor of Business at University of Technology, and I've got to say I had no idea what I wanted to do. So I went into management consulting. And I figured this would be a great way of at least getting exposure to senior decision makers early on in my career. So in my early 20s through to late 20s, I was dealing with the boards of directors of some of the larger companies in Australia and outside of Australia. So it was a very good launching point for me. It taught me a lot about corporate processes, about being on basic stuff like being on time, presenting effectively, spelling things correctly, all that kind of stuff, because somebody's paying $4,000 a day for your time, but that was great in terms of making money and having a great salary, but it didn't do much for my aviation interest. And that was still there. Like I always had that passion for aviation.
When you were in college, were you even thinking about personal flight? Was that something that was in your mind back then?
Yeah, for sure. Even when I was at school, I started hang gliding when I was 14. I'm not even sure if that's legal. Maybe it is. Paragliding not long after that. I talked about the cliff jumping and what have you. And then I tried building my first jetpack when I was in my mid-20s, and I was starting to make a little bit of money with the management consulting, but the engines just weren't reliable enough. So it was always something that stayed with me. I wanted to fly, and I'd started flying fixed-wing aircraft like little Cessnas, what have you, and I got my license. Then eventually I got my commercial license, even though I had no intention of flying. But that's, to me, sitting in a cockpit, surrounded by all of that metal and instrumentation and avionics and a big wing, that didn't really do. When I sold my first company, which was I built my own management consulting company in the end, which was specialized in mining in South Africa and Australia and Asia. And that's a whole different story that we don't have enough time for. But literally, I spent 7 years building up my own practice and never sleeping in the same bedroom, 2 nights in a row. That was crazy. Built up the biggest mining management consulting practice, sold out of that, finally had a bit of money behind me, and then started working on the jetpacks, more seriously, but also got my helicopter license. I still, helicopters are amazing. You can, I bought a helicopter, and you can land in tiny areas once you're trained, but it's not the same as being able to lift something out of the back of your, the trunk of your car, strap it on, and literally take off.
David, just so you know, we can hear you. Your image is sometimes frozen. It was frozen for about 2 minutes. Just letting you know that.
Okay, let me see what's happening here with the that might help.
Yeah. So one question about your education. I mean, you built a lot of things growing up. A lot of kind of you said all these things that you built. About your education choice, you chose business rather than engineering. Was there what do you want to talk about that decision, or was that why did you do that?
I decided that I didn't want to be a career engineer. I decided that I had wanted to do something entrepreneurial.
Yeah.
which would probably preclude me from being an awesome engineer and focusing my career on that. I was always very hands-on and interested in engineering projects, but I don't think that's something that I wanted to do for my career.
Okay. Okay. Now let's move towards your decision to in your life to build the first jetpack. Where were you at the time when you first had that idea, and how are you planning on executing that?
I just sold out of my consulting company and I moved to Dublin, Ireland, and started. You have Yelp in America. I started the equivalent company in Australia and Ireland and the UK. So while I was working on that, I said to my wife at the time, like, do I retire once this next gig is finished, or what do I do? And she said, look, aviation is your passion. She was fully supportive. Let's go crazy. Let's build the world's first real portable jetpack. And it took a hell of a lot longer than I imagined it would, and it cost a lot more money than I imagined it would. I actually started in 2005, and if you watched, there's a feature documentary called Own the Sky, and if you get to watch that, there's this crazy scene in it where I'm walking down this road in Los Angeles, and I said, it's 2007, and I'm feeling really good. I think we're going to be finished by the end of this year. Fast forward to 2014, and like literally, and I was still saying the same thing.
Wow.
And that was nine iterations later, several $1 million later. Just an extraordinary experience in failure. Every single day for that many years, to wake up, to try, to have a fire, to have an electrical problem, to have a computer problem, to go back, start again, with a very small team. There are only 4 of us.
Wow.
And then, we had crashes. We burnt down part of the building in one of the accidents. I had 3 stints in hospital.
Wow.
And so it was a labor of craziness. And finally, as you said, it was actually 2014 was the first time that I got the jetpack flying properly. And of course, I did all the test flying. I was the only qualified pilot on the team. Everybody else was an engineer, and they're flipping amazing engineers. But and maybe they would have done the flying better than me. I really don't know, because it's very different to flying a helicopter or a fixed wing. But I had to train myself. So every time I would go out to fly this, on a safety line, I didn't know whether the problem was the machine, because nobody had ever built something like this, or whether it was just I couldn't fly. The machine was perfectly good, and I couldn't fly a perfectly good machine. 2014, it all came together, and I finally flew off the safety wire up near Sacramento over a little lake, and then around the Statue of Liberty in 2015.
Right. Now, tell us, what I'm curious about is the genesis of the jetpack. Maybe we have a diverse audience of both some technical people in the audience as well as business. Maybe in broad strokes, where the technology was when you started your project, what the state of technology of jet engines and personal jet engines, and what innovations you had to make it really work.
Yeah, there had been a jetpack built by Williams Aerospace back in the 80s, but the engine was kind of the size of a largish refrigerator. So it wasn't portable. You couldn't walk around with it. So to build a smaller aircraft, we needed smaller engines and reliable, and still reliable engines. And nobody was building that. So we started off by trying to build our own engine and working with engineers, not full-time, but under contract, that had built engines before. That was a nightmare that took us down a rabbit hole for 18 months. Then eventually, some of the existing engine makers that were making engines for radio control aircraft started upscaling their engines to effectively drones, like ultra high speed target drones for the military. And so kind of as our path was developing, their path was developing with the technology, and we came together at this point in about 2012, where the engines provided enough thrust and were reliable enough in the right configuration for us to get off the ground. But up until then, there really wasn't anything.
Wow. So really from 2005 to 2012, you were building that first workable prototype in that time. It took that long.
Oh, yeah, absolutely. There were 9 prototypes. So during that time, we were building, between 2007 and 2014, we built 9 separate prototypes.
Wow.
So each one took nearly a year. Each one cost $500,000 or something.
Yeah.
And each one didn't work until the final one.
Wow. Now.
Yeah. Sorry, go on.
No, go ahead. Good.
I was just going to say, so it was the technology around the engines that improved sufficiently to make this happen. It was under our understanding of how turbo machinery works, so how small turbojet engines work as well, because we needed vertical thrust, not horizontal thrust like aircraft would have, and that meant we needed to change fuel systems, lubrication systems. So we learned a lot about that, and then on the electronics. As iPhones became more popular, and certainly as drones, if you think about that period, drones became a dime a dozen. You could buy a DJI drone for $1,000 or something. So suddenly now we had sensors that you could buy for, several $100s, that when I started this project were being sold by Rockwell Collins for $250,000 and were like larger than a shoebox. You have like 5 of those in your iPhone now.
Wow.
It's insane.
When you were during this prototyping phase, were you operating in fully stealth mode, or were you open and collaborating with others around the world?
We were fully stealth. Actually, we went through a phase. We were initially open collaborating, and then I heard through the grapevine that there were a couple of other people working on this kind of thing, and they were going to commercially, like aggressively commercialize it, and they were super, keen on IP, and they were going to protect everything and try and shut us out. So then I went into skunk mode. Like in 2009, I just shut down. Basically, nobody came to visit the workshop. We had a pretty big workshop in Van Nuys, California. They're just in LA, but nobody came to visit. When we were test flying, it was like a shutdown site. I became pretty paranoid.
Now, after your Statue of Liberty flight, tell us what happened after that. Did you then it's public. Everyone knows you're world famous now because you have this new technology. What happened after that?
Things happened pretty quickly. The first thing that happened is, we did a heck of a lot of press, obviously, while I was still in New York. And then the day I got back to Los Angeles, I received a phone call from a warrant officer, such and such, from the US SOCOM, so the US Special Forces, and they wanted to talk to us about the use of the jetpack, and could we come and do a demonstration over at Virginia Beach for the Navy SEALs. And of course I didn't believe it, because we're constantly getting crazy requests, and we're also getting some really valid ones as well. But I said, yeah, look, that's cool, but can you send me an email? So I got this email from a Hotmail account, and I thought, oh God, this is just getting worse. And then so I replied saying, hey, could you send me an email from something other than a Hotmail account? And I got this email from .gov.mil. So it was like a military account. I went, okay, fine. So this is real. And that started a whole project over 5 years with the Special Forces in the US, and training operators, showing them how they could use it in different use cases. Then working with Red Bull, they had a series of air races around the world, and we would fly at those air races, putting together our own air race team. So, but what happened was that actually what came out of the work we were doing with the Navy is that they wanted to build an aircraft that could carry at least 300 pounds. So they started with 220 pounds, and then they said, well, what about 300 pounds? And they also wanted to fly more than 10 minutes. So, it suddenly became something that you couldn't just strap on your back. It was getting too big. And the big thing was that they wanted to make it flyable fully autonomously, so that effectively, if you had a pilot in it, you could be flown remotely. And it's pretty hard to do that with the jetpack just because of the size of it. So that's where the speeder, which we're building now, came in. And we took that concept to Y Combinator and went through Y Combinator in 2019, which was super cool. So that they loved the idea of the flying motorcycle. And that's so, and we probably get 100 requests a month to, do some kind of flight somewhere.
Yeah, I definitely want to do a deep dive onto the speeder. Before we get there, on the jetpack, did you ever sell either the jetpacks themselves or the service in any way?
Yeah, we sold we sold the jetpacks to government organizations, and we've sold training services to them. And then, of course, that's to the government. Of course, in terms of civilian life, we've done a heck of a lot of, we've done TV commercials like Oscar Myers. We've flown all over the world for TV shows, for the Red Bull series, etc.
And you're still doing that. That's still a part of your business, right? Yeah.
Yeah, and people can come and fly the jetpack in Moore in California, which is like 45 minutes out of LA. So we have an operations center there that pretty much anybody can come along and like try the jetpack.
Do you believe long term that the future of personal flight will be with the jetpack? Do you think that will be a big part of it, or more on the motor, the kind of the personal flying motorcycle?
I think more on a very, it'll still be a very small craft, but it will be a craft that you can sit on. So rather than something that you wear,
right?
I call it the kitchen table test. It's got to fit on the kitchen table, and a jetpack you can fit 4 jetpacks on a kitchen table, but the bike will fit on a kitchen table. So it's still really small. You can fit 4 of them in a car trailer. It's just a little more practical because you don't have to carry it around with your legs.
Right.
But there's nothing that, like, the jetpack beats everything in terms of just being absolutely cool. Being cool. Being cool to fly, like being able to walk along and then just boom, take off. And it's so dynamic. It's like riding a bike in the air, like a motorcycle or something in the air. You can't do flips with it, but you can turn and like carve as if you're like riding a bike and banking. And when you want to come down and land, you can literally land like on a dock.
Yeah. Well, what do you see as a long-term future for the jetpack? What do you think is the dominant use case?
I think that there will be uses by like search and rescue organizations, medevac organizations, infill, exfil for military. So if they need, let's say you're in a valley and you need to get 3,000 feet up a mountain, and your options are to climb up that mountain or to drive an awfully long way around, or risk going, putting a helicopter up, which is a very slow moving target, and a large one. The jetpack would be very useful for that kind of thing. It's a 10-minute flight or a 5-minute flight, and you can go from a valley base up to the top of a hill, boom, very quickly. Right. It's useful for that. Positioning a medic, certainly for entertainment and for educating people on the future of aviation. I think it's awesome for that. So I think that the jetpack has that kind of role. We're working with some folks. Unfortunately, I can't name the country at the moment, but let's just say they're in Southeast Asia, and the government there wants to use the jetpack to be able to get medics very, very quickly to islands. So like if somebody's injured on an island, at the moment, it just takes them too long. That concept of the golden hour, getting hands-on with a medic. And with a jetpack, you can carry a medic, and you can carry another 10 or 15 pounds of emergency supplies and medic gear. and you can get there way faster than any other way.
Wow, awesome. That's fabulous. So I mentioned Richard Browning and his company Gravity. Do you know what are you just for anyone who's not familiar with what we're talking about? Just go to YouTube. There's some awesome videos. You can go to David's website, jetpackaviation.com. Is it fair to say Richard Browning is the other main player in the space for personal jetpacks? He's got it kind of on his arms, right?
Yeah, I think in terms of probably if you look at sophistication of aircraft, it would be Frankie Zapata in France, who's actually really close to where I am in France at the moment. He's got a lot of mechanical design and stabilization going on. Richards is effectively, strapping the engines onto your arm and onto your back, but with no airframe and with no control systems or anything like that.
Yeah.
And then also Yves Rossi from Switzerland, who was working in Dubai. They started to get into vertical takeoff and landing, VTOL operations.
Yeah.
Unfortunately, they did have one of their operators die 2 years ago in a crash in Dubai, which was very, very sad. They did have a parachute. Nobody's too sure what happened there. But this is experimental aviation.
Right.
So they're the main players. There's us. There's Frankie, Yves, and Richard.
Okay, now why don't we transition over to the speeder and tell us a little bit about the genesis of your flying bike. How much of that technology did you transfer over from the jetpack to the bike?
It's about 60 to 70% that we took over. A lot of the thrust vectoring and engine control systems. Obviously, the way that we mount the engines, the way that we fuel the engines in terms of the fuel pump systems and lubricate the bearings, that all cuts over. What is very different is the flight control systems. So with the speeder, we needed to actually move the engines in flight to gimbal them, to be able to rotate them forward and backwards. And we also needed to duct the exhaust. Now, with the jetpack, we duct the exhaust only for yaw control. That's like if you want to spin the aircraft on the spot. But for the speeder, we need to be able to duct that exhaust on 2 axes, laterally and longitudinally. So we needed to introduce electric servos for the first time and a flight control unit and build the code for that flight controller. Nobody had built a flight computer for a turbine machine. There's a million lines of code out there for electric VTOLs, and drones. But turbines don't react in the same way as an electric motor does. Obviously there's a lot of lag. If you give a throttle response, you don't get immediate acceleration or deceleration. So we spent the first year while we were in Y Combinator just doing physics modeling. That's all we did, which drove me mad because I love cutting metal and making things. But for the first year it was Simulink, MATLAB, and then we built the code out of that. We flew it in a computer, then we built the aircraft, and we flew it initially on the tether and then off the tether. But the speeder came out of the work that we were doing with the military when they said, hey, we want to carry 300 pounds. We want to fly for more like half an hour. And effectively, we want to do it without having to train the operator for a week.
What year, just a timeline, what year did you start at the speeder and when did you have that first prototype, the first kind of working version?
We started it in late 2018. We spent 2019 doing the modeling work. 2020, we started building. At the end of 2020, we flight tested on the tether, our first, what we call the P1. And then last year we built the P1.5. So that was the next full-scale prototype. These are all full-scale. And then we're now building the P2. So that's the third full-scale prototype, which we'll be testing mid-year this year.
So that's a lot faster. That cycle is a lot faster, I'm guessing, building off of the innovation from the jetpack.
Yeah, you're right. But also the team's a lot larger. So, we got our seed round done after Y Combinator. We did a seed plus round. So instead of being a team of 4 engineers, we're up to like 15 engineers and it makes a big difference.
I read your blog last night about this question about eVTOL, right? Electric vehicles.
Yeah.
And your opinion is that we just don't have the energy density of the batteries right now compared to jet
Right.
fuel. What's your being in this space? What's your prediction about? You said it's an evolution, not a revolution. Kind of slowly marching towards.
Well, the problem at the moment is we're advancing at about 2% per year in terms of improvements in energy density. We talk a lot about solid state batteries and different chemistries and what have you, but we haven't seen that revolution. We haven't seen anything jump from, say, 220 watt hours per kilo to 500 or 1,000. And to be honest with you, nobody knows when that's going to happen. And a lot of the eVTOL designs that you see out there at the moment will not perform their mission as the entrepreneurs or the founders want that aircraft to perform with the current energy density of batteries. They just won't be able to. So their choice is to either fly sub-performance. So if they thought they had a 30-minute endurance, they're going to fly for 10 minutes instead, or they need to go hybrid. In other words, they need to have some kind of electric generation system in the aircraft, whether that's a diesel generator, a turbo shaft, turbine engine, or whatever it is. And for us, our customers want something incredibly small. It's impossible to build something really small using electric propulsion because you need to swing fairly large propellers. Once you do that, you just get bigger and bigger. Also, you need to carry the batteries. So to carry the batteries, your props need to be bigger, and you go around in a circle, and it just doesn't work for something that will fit on your kitchen table.
Are you even considering building an eVTOL, or are you going to wait for that battery technology to mature a lot more before you do that?
No, we are actually designing an eVTOL hybrid, so it'll be a series hybrid system. We're designing that now. We're pretty keen on our green credentials. So the fuel that we'll be using will either be sustainable aviation fuel, SAF fuel, or it'll be fuel from air fuel, like from Prometheus Fuels or one of the other carbon dioxide capture companies that are converting carbon dioxide into fuel. So we can use kerosene or diesel, and we can get the equivalent of 14,000 watt hours per kilo out of that instead of 200 watt hours per kilo. Now, we have massive losses thermodynamically in the way that we produce thrust, but still we're like 10x ahead of electric. So yes, we are designing. It's quite cute. It has a folding wing system and tricycle landing gear. It's also for like emergency services. It's also to get somebody into a pretty confined environment, but it does rely not just on lithium-ion batteries or lithium polymer batteries. It also relies on, in our case, a small turbo shaft generator.
Now, let me ask you about the long-term use case of the speeder. Let's say on the civilian side, do you? I think you did remark in one of your blogs that it works for a city like LA, not so much New York, where people are spread out, and you've got sort of you still have you have a lot of traffic and congestion, but you still have enough space to fly between places. Do you imagine working on something like a shared system where kind of like the bird scooters, where people are they're owned by a platform and then you jump on one and hop onto another and leave it there? Or is it people buy these and own them yourself? What are your thoughts on the long-term economics?
I think there may be a small market there for recreational users. I don't think this is something that people will be buying to fly around cities anytime soon. I think it's more a ride share or a pay-per-use type model. For us to be useful in the urban air mobility, the UAM space, we will need to be electric. So all of our flight control systems will work for electric propulsion. We'll be able to pivot over to that once once energy density of batteries improves. The way I think about it, Krook, is that on the road now you have SUVs and you have sedans, but you also have vehicles that are really good at just moving one or two people around. I think the economics will be there one day to do that in the air as well. So, you'll have intra-city 4 or 5 seat aircraft like Joby or Archer or Eve, one of those aircraft. I think you'll also have some point-to-point opportunities with a much smaller, like 1 to 2 seat aircraft like ours. So that's really our target.
Why do you say that it's going to require electrification? What's wrong with sort of a network of your existing models?
Just the noise.
Oh, okay.
Using turbojet or even turbofan engines, because we are looking at turbofans, which is slightly quieter but still noisy. They are louder than electric propulsion. Having said that, there is this kind of misnomer that, it's electric, it must be silent. It's not true. Just
Right.
Physics says if you want to lift something a certain size, you need to accelerate, a certain mass of air. That makes noise. So all of these aircraft are going to be noisy, and I think it's unproven just how well the public will react to regular, routes back and forwards over a city of these eVTOLs. We don't know that yet.
Yeah. So we're still a ways away since the electrification hasn't happened yet. That technology is not ready yet. We're still a little bit away from execute on the full.
You can get short ranges with electrification now without a hybrid power source, but you can't get long ranges. And so I think that what we'll see fairly soon is some specific routes. Like in LA, it might be LAX to somewhere downtown where the vehicle can fly without upsetting, the residents underneath, maybe following one of the, LA canals or something. And so there'll be a couple of specific routes in areas like LA, or it might be Dallas or Florida,
Right.
Florida, in Miami, etc. We'll see that in the next 5 years.
Wow, that's awesome. Do you see yourself long term as just the producer of these machines, or do you actually see yourself as the platform doing all the ride sharing?
We'd actually love to see ourselves as an operator, as a platform. Yeah,
Okay.
it's not our. I've got to say that's not our our company's intellectual property around at the moment is around turbo machinery and the engineering associated with flight control systems. But I think that the commercial model here is really interesting around operating.
Wow, that's awesome. That's great. I also saw you have good relationships with the FAA. Tell me, how has the regulation been, say, in the US on personal flight and VTOLs, in your opinion? How can it be better?
It's speeding up, Krog. It's getting there. I think the FAA, and they'll admit this themselves, really got behind the 8 ball on drones, and China won that game. With DJIs and what have you like that. The FAA just didn't get their head around the regulations fast enough, and that got away from them. So they're very much on the front foot now in terms of eVTOLs, and they want to lead in that space. No eVTOL company has gone through a certification program, what's called a Part 23 certification program yet. None of them have. Some of them have applied for the starting process for certification, like Joby, but none of them have gone through that process. So it's a bit unknown at this point, and I'd like to see us not be the first group to go through that. A lot of our use cases are either public use or military use, so we don't need FAA Part 23 certification. Having said that, we're working with the FAA right now to get at least experimental certification, R&D, for our speeder, our flying motorcycle, just so we can test. Because we want to start doing 400-mile-an-hour flight tests in the desert in California. Right. And for that, we need at least R&D special airworthiness certificate from the FAA.
Is there any infrastructure you need from that's owned by states or governments for this to work? It's not like, or no.
Not really. I mean, it's so small and it can land in a very austere, unimproved environment. We really don't need anything at this point.
Okay. Okay, great. Just to tell people in the audience, so Texas is doing a lot on autonomous transportation. We have a conference coming up in 3 weeks in Dallas on autonomous transportation. Fort Worth actually is trying to make a big splash on all different kinds of autonomous transportation, including drones. I think there's a big section on drones. I'll tell you more about that, David, offline.
Yeah,
and I know that Texas is competing with the other states in trying to loosen the regulations for more testing and more experimentation here and I think we are competing. It's a lot of with California to try to make sure we get as much of that autonomy here.
I think everyone seems to be leaving California at the moment.
Right. That's right. Awesome. So so now tell me about the on the speeder, the military applications also seem to be military and emergency applications are the main use cases you see. Is that right? Or do you see other commercial applications?
No, I mean, there's a couple of different applications there. And very ironically, one of them is to get electric power to the front line in a battle environment, because they are electrifying a lot of their ground vehicles, but they're not sure how they're going to get electric energy to recharge these vehicles on the front line. It's one thing to do that at a forward operating base or a home base, but how do you do that in a very austere environment? So one of the things they're looking at is, how much energy could a turbine powered jet speeder flying motorcycle carry into, if we could lift 1,000 pounds or 2,000 pounds of lithium ion batteries, that would be useful for them. And we can swarm. So we can do that with 10 aircraft, and it's still cheaper than, half a helicopter or 2 helicopters.
And you have a fair amount of autonomous technology in the speeder itself is that right? For stabilization?
Yes. Yeah.
And the jetpack also?
No, not so much with the jetpack. That's
okay.
What we had to develop for the speeder.
Okay. Let me turn to a few of the questions from the audience. So some of these you've covered. The fuel power source for right now is jet fuel or kerosene?
Yeah, any kind of heavy fuel. So paraffin, diesel, kerosene. Obviously not gasoline.
The noise. I have a question about noise. Noise is a concern for both products, right?
The noise is a concern for the jetpacks and for the speeder, but not really for the use cases that that our customers want to use them for. They don't care about the noise, because you're saving somebody's life.
Right.
And in the case of an emergency use, then so far there hasn't been any concern about noise. Okay.
You did answer this question about plans to move from fuel power to electric. We'll skip that one. Talk about environmental concerns. How do they factor into decision making, either through battery disposal or gas emissions?
Yeah, I mean it's a really good one, and it's tricky because people need and want an aircraft the size of the speeder, which is like a motorcycle, because only in that size can it do what they want. They have to deploy it from a very, very confined area. They have to be able to store them and transport them. So it's impossible to do that with electric energy. So we're kind of squashed at the moment that we need to use hydrocarbon fuel. So the best we can do is use SAF, sustainable aviation fuel, or carbon capture fuel like Prometheus fuels, which gives us a net zero result. But that will probably continue for the next 5 years until we see electric energy improving. The eVTOL that we're building still requires some hydrocarbon fuel, which may be, again, SAF or Prometheus fuel, because it just otherwise won't have the range and endurance. Okay.
Another question. Have you considered using Utah test and training range? Utah is driving hard for national security innovation ecosystem. Do you know anything about that?
Did you say Utah?
Yeah, Utah.
No, I don't think we have talked to you. I don't think we've talked to Utah yet. I'd have to talk to some of I'd have to talk to our ops guys. I know Ohio. We're talking to a bunch of different places.
Okay. Do you see policymakers allowing common people to own these machines? Is that something long term you think is possible?
That's a great question. Not in the near future. Not in the near future. The speeder has such extraordinary capabilities that you would have to, even though it can be operated fully autonomously, if a person is riding it, there's a whole lot of training and qualification that they would need to have. And
right.
Then there is the infrastructure in terms of ATC, air traffic control. If you've got a whole bunch of individuals using this, how are you actually mapping out the separation? That would have to be done autonomously, and we're not there yet. We would have to be without a human in terms of air traffic separation. So look, I think that, we could sell either the jetpack or the flying motorcycle tomorrow, or as soon as it's test flown, for recreational use, but it would have to be very limited in terms of capacity. Like the speeder can do over 400, nearly 500 miles an hour.
Wow. Wow.
So
how fast have you gone on each of them? I'm curious.
Well, the speeders, all the flight testing of the speed has been unmanned so far.
Okay.
And the fastest we've gone is about 200-ish, but the modeling,
right.
You couldn't do 500 with a pilot sitting in a motorcycle position. You can't do that speed. In a cargo mode, where you have a very nice sort of teardrop aerodynamic shape, that's where you can do those sorts of speed. With the jetpack, about 120 miles an hour, we've flown it at.
Yeah. And how high have you gone in the jetpack for this?
Not that high, because we have no parachute. We have no parachute system.
Right.
I think the highest is probably. It's still high.
Still high. Yeah. Anything above like 30 feet is high. So.
Yeah, you're absolutely right. I think probably 150 feet or something like that.
Wow.
And I actually did that flight, and I ended up at that height because I was following a drone for a movie. And they said, "Oh, look, follow the drone and like keep looking like you're looking at the drone." So I followed the drone. I didn't realize the drone was climbing like heck.
Wow, was that scary, or what did you think?
Yeah, it was scary when the drone broke away at the end of the shot, and I looked around for the first time and went, "Oh, how did I get up here?"
Wow.
So yeah, I came down pretty quick.
Wow. I'm curious about actually the funding of your company. At what stage did you, if you're able to disclose, take external funding in the life cycle?
Yeah. So I started on this just before 2007. I funded the first just over 3 mil myself after I sold the Yelp equivalent company. That took us through to 2000. The New York flight, Statue of Liberty flight, 2015. So we raised the first external capital after that. Got a lot of interest, obviously, from a lot of folks around the world. But I wanted to retain control and not go crazy with a whole lot of shareholders. So we just raised $1 million in angel funding, and then we went into Y Combinator there and raised another 2 million, sort of on better terms, and then have raised a couple more million since then.
I'll tell you that one thing I'm concerned about is that in the US, if you think of the last 70, 80 years, it's right now, I think we're getting out of it, but right in the last 20 years, it seems like we were aiming a little bit low in terms of our innovation. I think a lot of people got caught up in software and building mobile apps. And in colleges, for example, everyone was trying to build either social media or a dating app or a food delivery app, and they sort of gave up on the big stuff. And I'm wondering, is that cultural, or is it actually because it just requires a lot of capital up front that a lot of people don't have? Just curious your thoughts on that.
I mean, I think that there's been a massive explosion in, as you say, software is the way. Software will solve all our problems. Software will rule the world, and a lot of the capital thinks that way. They think about growth rate in numbers. ARRs. Cost of acquisition of customers. They think about that rather than deep tech. Like deep tech takes a long time. It's highly risky. But as does a lot of biotech, trials and that sort of thing. Like you don't know. It might be 5 years before you have any idea. So, I mean, there are more funds now that are willing to take a shot at hard and deep tech than there were, 5 or 10 years ago. So it is coming around. I mean, like when we went through Y Combinator, we were one of the very few hardware companies. One of the very few.
Yeah, one thing I've noticed in Texas, actually, I think this could be one way Texas can position itself different from some of the other states, is that we tend to be a little more hardware focused, and we have strengths historically in things like robotics, transportation, energy, advanced materials. A lot of technology come out of universities like Texas A&M. And I'm optimistic that the tide is changing, but I definitely feel like we're still running an uphill because the conversation, the national conversation, is still largely about software alone. I'm designing a new class actually next year called Moonshots, and it's specifically trying to get students to think big and to solve problems in our physical world, not just in the virtual world. So,
right. I mean, I think a lot of the space startups are helping though.
Yeah,
we're seeing the success with, obviously SpaceX, but Relativity, and there's so many space companies that are doing so well, and I think that's opening up people's minds to hardware and to big risks, like big shots.
Yeah. Now, David, let me ask you to put yourself in the perspective of some of our students who are thinking about maybe walking down this path. They're interested in either aviation, entrepreneurship. They want to take a moonshot. What advice do you have to them? Let's say a 22-year-old graduating from college, for the long haul. For what would you take? What lessons from your own life that you would like to share with them?
Get involved in something interesting. Don't go work for Lockheed Martin tomorrow or Raytheon or something like that. Find a nimble company. I'd say like Jetpack Aviation or one of the VTOL players, and just do whatever you can to network in and get a job in one of those companies early on. That's what I would say. And then if you've got a passion in aviation, do something yourself. Like if you're an engineer, build something yourself. It doesn't matter what it is. One of the things that we've been looking at a lot is what are the engineers that we hire? What have they actually built themselves before? It might be a speaker box or some kind of mechatronic system or what have you, but not just, and I would say not just a school project, like not just a college project, something that you've done completely separate to any of your education facilities. That counts for a heck of a lot.
I tell you, I completely agree with that. And I will say that higher education, where I spend all my time, doesn't do a good enough job providing those opportunities for students to actually innovate and experiment on their own. And I wish, it's surprising. A&M is a very good engineering program, but I'll tell you, talking to students across the college, it is fairly theoretical, and we don't have enough. I mean, they get kind of a capstone in their senior year, but that's kind of it. They need more opportunities, I think, to innovate. Yeah. Right.
But if the guys are very passionate about getting into aerospace, then they need to do something, even if it's completely off their own bat, to demonstrate that they're really interested. And that's what we look for.
Okay, perfect.
Yeah.
Well, David, thank you very much. This is super interesting. I want to thank you both for your time and for doing what you're doing. I mean, this is really amazing technology. It's kind of an inspiration to all of us. across universities and for young people. And so we do hope
Thank you, Cora.
we do hope we can host you in Texas at some point. We'd love to somehow find a way to get you here and show off our campus.
Yeah, I'd love to get over there.
Yeah,
I'll bring the speeder.
yeah, exactly right. Exactly right. That's right. Everyone's moving to Texas anyway, so you just have to join them.
We'll rip up some 500-mile-an-hour airspace.
That's right. Exactly right. Okay, thank you, David, and thanks to everybody for showing up. We will email everyone the link to the once we get all the websites together.
Okay. Good luck
Okay.
to all the students. Yeah. Good luck and thanks, Karok.
Okay, David, are you okay with us putting this on YouTube, or would you prefer not to?
Yeah. No, that's
You're fine with that. Okay, great, perfect. We'll do that. Great.
Lockheed Martin and Raytheon will be so happy.
Yeah, right. Exactly right. Well, hopefully you'll put them out of business one day.
Yeah, exactly.
Right.
Or they'll have to buy us, and the price is going up.
Yeah. Right. I'll tell Tim you said hello. I should see him in the next few months. So.
Yeah. Awesome.
Okay. Okay. Great. Thanks, David. Thanks so much.
See everyone.
Okay. Bye.